Alright, so welcome back. Here now I'm going to look at the Node.js course from Zero to Mastery, and especially looking at a quick overview of what I have learned so far with GraphQL. Especially what are the issues. So what is GraphQL, which is a new query language, uh, a new way of building APIs and interact with them, where it's much like selecting objects in a property, and it all starts by describing the data using a schema, and then using GraphQL queries to ask for the data that you want. So the beauty of using GraphQL is that since the query really match closely the resulting object, we can predict what our query will return, including its property name, okay, regardless how the data is stored, whether it's a relational database, document base, key value, graph, or Y column. And it was created by Facebook in 2012. And the main issue that it solved, that is a common thing in RESTful architectures, like, well, underfetching and overfetching. So underfetching is that any time that we make a request to query multiple collection, uh, we lose some we lose time anytime we make requests to query multiple collection of value multiple collections, and that yes, I just want to paraphrase that. Blah, blah, blah. Okay. Underfetching, the problem it solves is that any time that we query or any time that we request multiple collection of values, or any time, so Jesus, we lose time. Yeah, we lose. So anytime we make, just to reparaphrases this, so anytime we make a anytime we make a request, Jesus, it's just I just want to put words. I just want to mention this uh, in a succinct way, and also to kind of help me here. How can I compose different verbs to create a sentence? So underfetching, the problem, or what underfetching is, that anytime we make additional requests, we lose time querying multiple collections, and that ends up adding load times, increasing is the waiting load time for users. So in other words, okay, which is here, if I recall that, right. So underfetching is that we lose time anytime, okay, but we lose time, okay. So we lose time making extra additional round trip uh, uh, okay. So we lose time making extra unnecessary. Yeah. So there's two factors here. We lose additional. It is important to understand these two issues, right? So we lose time making extra additional requests between the server and the client. So we lose time making additionally uh, we lose time making unnecessary additional requests between the client and the server, and do more work querying multiple collections, which slow down page time. So, what is the thing that take me so much to understand here? Since there are two problems here that underfetching has, that we lose, or yeah, we lose time. Yeah, we lose time making additional unnecessary requests from the client to server, and do more work querying multiple collection. Yeah, and querying multiple collection, which slow down page load time. So I understand is the issue with the request, and by querying multiple collections, perhaps at the backend, if you're querying multiple collection of data in the backend side, not in the request side from the client to server, but at the backend, okay, uh, you do more work to querying multiple collections, meaning that the server perhaps needs to query multiple collection or tables if you use, for example, a relational database, or collections if you use a document-based database, which slow down, and this is one of the key aspects here, which slow down page load time. And what's more, well, that each of those requests might contain data that we don't need, and that is the overfetching the problem. So mean that we're sending unnecessary additional data from the server to client, and the browser needs to filter out the result to show relevant data. So this is the two main issue that GraphQL solves. All right, and by understanding this might help you to also understand what will be the common theme of problems you need to solve, especially in Node.js applications, right? So, for example, reduce the number of requests you make to that endpoint, all right, from client to server, and the number of query from the backend to database. Okay, so reduce the number of query and reduce the number of reduce the number of requests and the queries. So okay, and we have the front end, the back end, and the database here. Okay, so by reducing is the number of requests and the queries. Okay, we also GraphQL also solve the issue of sending unnecessary additional data from the server to the client. So a perfect use of GraphQL is e-commerce. Okay, so GraphQL solves this by having one single entry point where you ask for all the data that you want, and you hopefully can get the result that you need. So having this single entry point solves the underfetching problem, since we don't need to make additional requests, and what's more is the server doesn't need to do, or doesn't need to query. Well, that's relevant to that on based on the implementation, but the server doesn't need to query multiple collection of data. Okay, from the front end to back end, the number of requests has been reduced to a bare minimum. uh, and also the bandwidth. So the waiting time has kept to a minimum. Okay. Uh, and the other is the overfetching. So where's the advantage and the disadvantage of this approach? Deflect. So there is no more underfetching, no more overfetching, and it is you have schema and types, and it speed up the development. So the trade-off or the disadvantage is that this flexibility comes with a price, comes with complexity, because now you need to learn how to build and interact with this type of API. Uh, the catching methods are very difficult. It's not impossible, even though they provide you some GraphQL docs to do that. But since developers has used to the RESTful architecture, which is one of the another disadvantage, it's not at RESTful. Most developers are familiar with that. That has been decades with that pattern or that architectural style. Uh, Now they need to dedicate time to learn that. The learning curve of knowing, or the learning curve of GraphQL. So, all right. So also I look at the implementation website and also how when you can use this GraphQL with React framework and Apollo, which is a tool that allows you to build front end and back end GraphQL servers. And before using this full battery uh, tool, before using this tool, full battery include, I want is to the zero to mastery structure may us to create a GraphQL server from scratch, and that is using an Express and an Express middleware with GraphQL. So we can see how by importing the GraphQL package in our server, see how can we create our type system, okay, as a string, where here is where we can define all the GraphQL server capability that is used to determine if a request operation is valid, the type of the response result, and if an input value, and to determine the input value of a variable uh, to verify if that is valid at request time. So now, uh, well, as we move on here, I started to define is this using the build schema for that. Almost an all GraphQL server has the type query as the entry point. Okay, uh, and then I look at the basic aspect here of making an HTTP entry, making an how to test your GraphQL endpoints using tools like Postman or Insomnia, or using an HTTP post verb, and then passing is a raw JSON for that. And then I look at designing an e-commerce. Again, this is to starting to see more real life applications or real life projects, and uh, since deep nested objects are very common in e-commerce application or any application that has some degree of technical depth, GraphQL is a great candidate for that because make it very easy to query really complex data structure and get the data that you want. So instead of organize our APIs with types and fields, which uh, which is the GraphQL server, now we have our GraphQL API servers organized in types and fields rather than endpoints, like in a RESTful, which makes querying multiple collections unnecessary, thus saving times and research and also money. So I started to look at using as a GraphQL tool specifically if you want to create more scalable applications or GraphQL servers apps by asking a couple questions like how can we organize our type into multiple files? How can we organize our server by features, which is how most GraphQL server at scales uh, are organized. Uh, and how can we uh, organize our it's someplace. I think the question is more interesting like that. So organize our server here. Is this? I don't know. Is this? So organize our server when we need to. How can we organize our server when we need to add more complex logic to fetch our data, which is the case of using resolvers. So after I look at how can I modularize large GraphQL projects schema, okay, by using and relying on tools like GraphQL tools, where you can use is the schema package and the low file package. Schema allows you to define is the type system and the load file uh, to import all of the GraphQL files and concatenate into a stream, which is something that we did here, right? Especially in the type array. There's a low file sync, all right? So wait for all of this file, wait to load all of this file with GraphQL extension here, okay? We can also rely on built-in tools like a path to actually get is the local root folder structure or the current folder structure, and from there iterate through giving a particular regex function through all the entire project folder structure, or based on that particular pattern that you provide, then uh, to look up and load for all of the GraphQL files. Okay, here we just uses the option here that the GraphQL tools package provide, the load file for that, and that was easy. That was something very very easy. And the great thing of this approach is that as long as your type here, as long as your files or types are well defined, okay, as long as your types are well defined and there is no name conflict, so you can use this approach. And then I also look at another component for any large GraphQL app, and that is resolvers. So to answer the question was what are resolvers, since it lies on the how we make a query, or what happens when we make a query. So GraphQL always determines if a query is valid by looking at the type, or by looking at the schemas or the type file, the type system. So by looking at our schema and then execute it. When execute that query, okay. So when executing that query, the value of each field is determined by a function called result. So when executing that query, the value of each field is determined by a function called resolver. And when a field is provided so when you're creating your query, right? So when a field is provided in a query, much like that, I think we're already running is graph, of course, or server compliant because it doesn't know what is that. So when a field is provided in a query, a resolver is called. Okay, when a field is defined in a query, a corresponding resolver is called. So when the server calls here, when the server here like that. So when the server has called for this, so when the server has called all the resolvers, it wraps up and then send it back to the browser. So I'm making this huge overview is first to solidify my knowledge on what is GraphQL, what are the problems that it solves, how it do that, what are the specifications, what are the tools that you can use, and how to do that from scratch, and then understand the reason why we have this high-end solutions like Apollo, for example. Okay. So when someone asks you what are resolvers, you can start is what describing is this story, right? It'll start by understand what happened when we make a query. So GraphQL always determines if a query is valid by looking at the types and then execute that query. So when executing that, to determine the value of a property, a function called so when executing that query, the value of each field is I just want to explain that with my own words. Okay. So what are resolvers? They are one way to do that is to explain the storytelling or tell them straightforward. I will incline is to explain things as a story because that's give context and more meaning. So the answer lies is on what happened when we make a query. So GraphQL always determine if a request is valid, and if it is, then execute that query. So when executing that query, the value of the property is determined by a function called resolver. And In the GraphQL here, the GraphQL, in the GraphQL, so in the GraphQL, in the graphical tool, so when you define a property in a query, right? So when you define a property in a query, a proper resolver gets called in the server. So in the server, uh, all the so when the server, yeah, in the server. So when you make a query in the server, or when the server has called all the resolvers, okay. So when the server has called all the resolvers of that query, it wrap up and then send it back to the front. So that's the explanation of what is a resolver. Uh, and then I look at how can we make a resolver. What are the problems that a resolver solve? So what are the problems it solves? Uh, and especially is to perform any async operation or any async database operation. Okay, so instead of relying on our root value in our case, so instead of relying on the root value from our hard-coded data that is not realistic, so we need a function called resolvers. So the way of using it is that GraphQL calls the required, yeah, GraphQL calls of the required resolvers. We fetch the data that we need inside of the resolver, inside of this function, and then the data is sent back to our client. And well, that's actually what we did here. So I look at the pattern and arguments and context and info here. So for example, look at the type def and type arrays, especially using the GraphQL tool here. All right, it's the GraphQL tool. So like resolvers, and here where this is where you define is this function that determines the value of the property here. So in our case, we are using, or we are mimicking a async operation by relying on the promise, okay, and return that product. And once we make this query here, well, voila, we already have is the data. Uh, on the front end, nothing has changed, and on the back end, now we are fetching is async data from that. So I also look at the property to where we can use here in our query. So for example, like parent, this is the value, or this argument, start with the root value. We have is the R, which is being used when we have a parameterized parameter parameter parameterized parameterized. Okay. So R is being used when we have parameterized like that. So R is being used when we have parameterized. So R is being used when we have parameterized. Okay. arg is being used when we have param, parameterized parameterized queries. Parameterized query. I'm not used to that word, but the more you practice in a given context, the better off it will be for you. Yeah, the better off. So arg is being used when we have parameterized queries. So arg is being used when we have parameterized, parameter, parameterized, parameterized, parameter, parameter, parameterized, parameterized queries. So arg is being used when we have parameterized queries. For example, filter out data with under some condition. Okay. So when we have parameterized data or queries, uh, for example, filter out data with some conditions. Context is for data that can be shared across, or that can be shared all across different resolvers. For example, if you want to pass authentication data about which user logging into every one of all resolvers, info contains some information about the state of our operation, like that. Mhm. So the parent start with the root value. Arg is being used when we have parameterized query. For example, filter out data with under some condition. Context is data that can be shared all across different resolvers. Uh, for example, if you want to pass authentication data about which user logging into every one of all resolvers, it's a very interesting use case for that. Okay? Info contains some information about the state of our operation. Okay? So the beauty of this is that now we can make API calls for async operation, and that is the data that our server will send back to our users. And then I look at, or starting to look, modularizing large GraphQL projects, resolvers. So first I look at how can I modularize uh, large GraphQL project with schema, and now looking at with resolvers. Let me make a pause here right now. What is this? Modularizing large GraphQL projects. Here, okay.
It's going to be a good one, so I'll see you there. Organize our resolvers in large GraphQL projects.
Yeah. So how do we organize our project? Just like we did with our schema, but in this case, with our resolvers.
How do we take advantage of our more modular folder structure that we introduced for our schemas? Just like we did with our schemas, our resolvers can also be loaded in based on some file path, thanks to this excellent load file sync function from our GraphQL tools library. Let's say that our resolvers are split up so that the orders resolvers live in the orders folder under a orders.resolvers.js file. Oops, and I need to make sure that's JS. And products has products.resolvers.js. We can now call inside of server.js this load files sync function to look for that file name pattern. So just like with our .graphql files, we're going to use the path.join function to look inside of the current directory, and we're going to join that with this file pattern.
Yeah. So in here, it's going to rely on the load file sync, but for the resolver array, right? So if we going to define here a variable called for the, it's funny how he start to describe what are the things he's going to do, right? It all start by, well, I would like to load a file, right? I would like to load a file, which is load file sync, and since we're going to use is the options property, okay, where you tell them is first come on I think it's this, okay. Here you tell a hey, I just want this to check out for the entire project folder structure, okay, and as a second argument, which is the option, check for files that end with JavaScript, that end with GS. That might be one way to do that, but if you do this, this is something that it will look up for all the JavaScript files that we define, and we don't want to do that.
That looks inside any subdirectories for a file that ends in .resolvers.js.
This is the pattern that we want is to look at. Oh, but since we say resolvers.js, question is, are you going to get all of that? So we have to tell them here is, hey, I just want us to check out for all of the files that have resolvers as a prefix for that, right? And we're going to assign this, okay, so we're going to assign this to a variable called resolvers array, okay. And so what we're gonna do is to create a file for our resolvers, like orders.resolvers.js, where we're gonna get is the product and query, but I would like to see how he does.
We're going to take those resolvers and pass them into a resolvers array. This array can now be passed in to make executable schema in place of our resolvers object. we'll remove our old resolvers and just pass in resolvers array. Now, how would we write our resolvers in a more modular way? We know that we want to export from our module, so module.exports an object which can...
Okay, so what we can do here is, since we're not going to rely on this object, and here we're going to pass is the resolvers array variable, or counts in your case. So here, if you want to pass this as an object or as a model, we rely on the model built-in in Node called model, and the property export as an object, not an array, as an object. That we'll have is the query for the orders, okay, and a folder, a file called product.resolvers.js, where here again we're going to rely on a built-in model from Node called model.export property, because we want us to export this file as a common JS model, or depend how do you define that. And here we want us to export as a, I think we have to do this as a query here as well. This is something that it will clarify me. Okay. And this should work, right? We're not changing anything right now. So we only change the way how we organize that. So by execute the query here, we already get exactly we get the data that we want. So making this pattern something that really something that works. Okay, so it works. Cool. No, okay. Okay. It
contains this quick module.exports, orders, and that's not very realistic e-commerce application. Let's use...
So, since we make, so far what we did is just to create resolver function that are just getting is the data from the root value, right? Again, this is not very realistic. So to actually mimic that behavior, what we can do is to rename the model here and tell them as product, and say, hey, you know what? This will be is product. Orders.
This pattern
or in our case is going to start with the product, but product model.
Our example here are they decided that's not very realistic. In large-scale projects, we would have a... But we've already decided that's not very realistic. In large-scale projects, we would have a products model that contains functions.
Mm-hmm. No. What the fuck? Oops. With hard-coded hard-coded data is not very realistic. Yes, this organized resolver function with hard-coded data is not very realistic.
Like, for example, a function to get products model parent.products, but contains functions like, for example, a function stick. In large-scale projects, we would
Mhm. In large-scale project,
have a products model that contains functions like, for example,
you have you have the data layer. You have the data layer. For example, product product model.
a function to get all products. And this function would make whatever API calls and database queries.
Exactly. And this function will make whatever API calls
To get all the products in our
will make whatever API calls to get. Yeah, we'll make whatever API calls we need.
e-commerce application. Let's
So for example, is this. For example, so here the data layer, which is between the server that handle all the requests, incoming requests, and send that handles incoming requests from the client and send requests to the database or any other servers. This data layer is usually or is generally usually on the product model. Okay, it's usually generally on product model. So here is by creating a function called get all products, where here is where you're going to make your API call.
use this pattern in our example here. Our array here is our in-memory database. So
Exactly.
let's assign that to a constant that we'll call products. And our get all products data access function in our model is taking our in-memory database and listing all of the products. So return.
Yeah. So we're taking all of our in-memory database. So we take all of we take all of the in-memory data products. So we send that.
everything in our products list. Our model will now export all of these
our
data access
model
functions
is
to
now
be
going
used
to
in our
export
resolvers. So get all
all of
products
this
is our one export
data
from the products model and to be used in our resolvers. So taking our in-memory, all of these data access functions to be used.
exactly. So our model is going to export all of the data model functions.
Used in our resolvers. So get all products is our one export from the products model.
And this is something crucial when you define this. So our model will export all of the data capability.
Return everything to be used in products list. Our model will now export all of these data access functions.
So our model will export all of this data layer, all of this data
Functions to be used in our results. Our model will now export all of these data access functions
all of this data access function. Okay. All of these data access
to be
functions
used in our resolvers.
to be used in our resolvers.
So get all products is our one export from the products model, and in our orders model, we'll do much the same. We'll set our
Yeah, and in our orders model, we're gonna do pretty much the same. Define is a function where you're going to perform all the API functions or operation. Okay, since right now we are storing is well, no, this is a resolver. Exactly. So what I'm looking is on the orders model. So since here we're hosting is this, so here we're defining is the function where we want to make all of our API calls, get all orders hypothetically, and return a list of orders. But first we need to define here a const called orders, since now we are storing is this data in memory, and return orders. So this model what is going to export is all of this data access function, like get all orders. So our resolvers can use this. So here what we're going to do is to import that using the required built-in tool from it's funny because it doesn't allow me to complete this, but here I want is to get is, let's say, oh, say product here, product, product, product model, and here calling is the required method from the No, it's here by the way. From the product dot model.
List of orders that orders model equals require from the current folder orders.model.
In our case, it's from product. And here, so what we're gonna do is, instead of making this as parent of product, what we're gonna pass here is the product model. Interesting. Require okay, it's because the new language feature the server will not be restarted. Okay, doesn't matter. In our case is get all orders. In here is get all products. And pretty much the same for the orders resolvers. Where here you're going to define is, instead of the problem model, the orders model, and import is the orders dot model. And here you're going to return is the order dot model get all orders for that. And this is a function. We need to call that like that. We need to invoke that. The same for this, because we want to invoke that function, uh, not pass that as a reference. Okay, okay. Okay, so if we restore the server and we run it again, now our server here, when we execute the query, expected iterable but did not find one for query products and query products. Line 33 and line 36. It seems we have some issue here. Orders model get our orders, and is here we probably get all. So what about if we check here? After all we are exporting is this, of course. Now we find the problem, and now they're supposed to work. Expected iterable but did not find one field for the field query products. Bad orders. Expected iterable but did not find one to field query.order. Expected iterable. In the orders model, in the product model, red shoe right here. So we're calling this in our resolvers for the product and the orders. Here you're calling is that correctly.
And now we no longer need to rely dot get all orders, and regardless of whether that's an async.
Perhaps I'm not calling that correctly. Orders model. Exactly. I'm not calling that correctly. So on here, orders dot model, and now if I rerun this, and it throws me an error because it says like exactly product resolvers and orders model orders is in singular. And the error it was here in the server line here exactly because it's model. All right, and now finally when we execute the query, we should get is that proper data, but for some reason we got a this error. Expect iterable did not find one for the field. Interesting. Uh, hmm.
Synchronous function or a static value, the correct data will be returned as possible and use the functionality in, for example, access a SQL database, don't need to change dual projects to look like it correctly with module.exports and not module.export. There we go. Now in
Model.export here. Model.export. In our model, we are exporting that model.export. Okay, for our orders and the products as well.
the products resolvers, we can import this function. So we'll say const products models. And there we are.
It's like we're not importing that properly. It's like orders dot model model dot get all orders, and product resolvers product dot model user from product dot model and orders dot model. Now it will work. Okie dokie. So if I query again for the data, I'm still receiving this error. Reload here, querying the data here, and still getting this error. It's required. You know what? Let me is products is an async version in return orders model get all orders require orders model and orders model. Okay, and he's not able to fetch the data. Similar for this. Product.model to get all products. Products.model. Okay. If I navigate to the product.model, is this. I just want this to return is this data.
Now in our server.js,
Because
we no longer need this root object, so we can remove that, and we no longer need to pass in these
the root value. So by removing this root value and also this, does it do any behavior behind the scene that I don't know? Products and orders are null. What about reload the data here? and now it sent me is this as no. Okay. Do I need to do anything else?
Default values into GraphQL. Instead, the data all comes through our executable schema from each of our resolver functions that talk directly to our models. This is a much more realistic, real-life GraphQL project structure. This is also how I would structure my own GraphQL projects. All right, our resolvers right now are super simple. In the next
But this isn't supposed to vary in anything. Perhaps I think so. Who knows? You don't know anything. Here you're saying is return is this. And also for the resolvers, getting the orders here, and getting the products here. What about if you restart the server? And if we reload here the server and we execute the query, it still get me this data as no. Interesting. Even though that I'm indicating that is required. Orders dot model. Orders dot model. Orders dot model. Model dot export get all orders. Perhaps I'm calling this the same for the product, get all products. For the product, get all products here. Okay. The hell is this? Let me restart here. Resources. Exit. Yeah. Let's see where we go. Open up. Restart the language server so I can get this auto completion. Exactly. Get all products. You return is the product, and for some reason, I don't know why you're unable. It's like you are not able to match them. Alright, come on. I closed that. This is the go. Oh, no, 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 no. Oh, yes. No. Open the recent prior here. Okay, it's running in the WSL. Some package. Da, da, da. Okay. Alright. Yeah, we need to use version 14 for that, and then start. Now, if I reload this, oh, hello now. It's still getting is the that's the well. What about product? There must be something. There must be something here. Yeah, because this is not about reference. This may be something internal, or I think it's something internal on the. It still says no. Why is that? Okay, it is pretty fucked up. It's pretty fucked up. Perhaps because I'm using this, but after all, he's loading his resolvers properly or not. Or I'm assuming that he's loading that properly. So if I say, hey, load sync file, get rid of this here. So hey, load this file .gs. Okay. What you're gonna need to use is the path .join. Using is the dir name, which contains the current folder value, following by this. Because I didn't import path here from, I thought it will automatically include that, require from path. Okay, alright, and then we execute this. Is that a shortcut? Control enter. Now you get it. Okay. Yeah, it's because the way how do we import that those files? Yeah, it was internal behavior of low file sync. Okay, internal behavior of low file sync. All right, all right. Yep, cool. So with that, I'm going to wrap up this section, which is take quite a lot of amount of time. And with that, well, take care. Bye bye.